a great Italian artist as well as a great scientist. Leonardo da Vinci once said, "Learning is the only thing the mind never exhausts, never fears, and never regrets." Learning to learn, a great Italian artist as well as a great scientist, not reject Leonardo da Vinci once said,
Yes, Sandhya.
"Learning is the only
Therefore,
thing
the
the
Faculty of
mind
Science,
never
University of
exhausts,
Kelaniya is here
never
to
fears,
encourage
and never
support
regrets."
fostering of
Learning to
multidisciplinary
learn,
research
great
and
Italian
innovation
artist
towards
as well as
excellence.
a great scientist,
wishing you
not reject
all
Leonardo da
the
Vinci
best and
once said,
Yes, Sandhya.
"Learning is the only
Therefore,
ladies
the
and
Faculty of
gentlemen
Science,
never
University of
exhausts."
Kelaniya
Welcome
is
to the
here to
inauguration
encourage
ceremony of
and
the
support
International
fostering of
Conference
multidisciplinary
Learning to Learn,
research
great
and
Italian
innovation
artist
towards
as well as
excellence.
a great scientist, not reject Leonardo da Vinci once said,
Yes, Sandhya.
"Learning is the
Therefore,
only ladies and
never lies
gentlemen
like
never
another
exhausts."
lamb. Kelaniya
Welcome
is
to the
here
inauguration
encourage
ceremony
its
of the
fame,
International
fostering of
Conference Learning to Learn,
multidisciplinary
great
research
Italian
and
artist
innovation
as well as
towards
a great scientist,
excellence.
not reject Leonardo da Vinci once said,
Yes, Sandhya.
"Learning is the
Therefore,
only ladies and
never lies
gentlemen
like
never
another
exhausts."
lamb. Kelaniya is
Welcome to the
here
inauguration
encourage
ceremony of the
its
International
never lies
Conference
like
Learning to
another
Learn,
lamb.
great
Kelaniya
Italian
is
artist
introduced
as well as a great scientist, not reject Leonardo da Vinci once said,
following distinguished
"Learning is the only ladies and gentlemen never exhausts." Welcome to the inauguration ceremony of the International Conference Learning to Learn, great Italian artist as well as a great scientist, not reject Leonardo da Vinci once said,
following distinguished
"Learning is the only ladies and gentlemen Faculty of Engineering. Welcome to the inauguration ceremony of the International Conference Learning to Learn, great Italian artist as well as a great scientist, not reject Leonardo da Vinci once said, "Learning is the only ladies and gentlemen Faculty of Engineering. Welcome to the inauguration ceremony of the International Conference Learning to Learn, great Italian artist as well as a great scientist, not reject Leonardo da Vinci once said, "Learning is the only ladies and inauguration ceremony of the International Conference Learning to Learn, great Italian artist as well as a great scientist, not reject Leonardo da Vinci once said, "The librarian of the inauguration ceremony of the International Conference Learning to Learn, great Italian artist as well as a great scientist, not reject Leonardo da Vinci once said, "The librarian of the inauguration ceremony of the International Thank you. This humble invitation is extended to the following dignitaries to take their respective seats at the head table. Chief guest of ICAPS 2023, Senior Professor Nilanthi De Silva, Vice Chancellor of University of Kelaniya. Guest of honor, Senior Professor Ajit Dialvis, Department of Chemical and Process Engineering, Faculty of Engineering, University of Moratuwa. Senior Professor Sudhata D. Kalingamudali, Dean, Faculty of Science. Senior Professor Kapila Senaviratna, Dean, Faculty of Graduate Studies and the Chairman of the Research Council. Dr. Chamila Kadigamur, the Conference Chair of ICAPS 2023. And Dr. Medha Gunaratna, the Conference Secretary of ICAPS 2023.
Thank you all. Ladies and gentlemen, please rise for the university anthem in respect for the alma mater.
Desakitu gosa urumaya suratin siat suwanda vidu kirana bedadena sarasandaki vidulakare udagina kalaniya sarasavi mata kalaniya sarasavi mata. Isuru sagalana Jai Jeeva Ulpadavanno Sindena Kalaniya Sarasavi Mata Kalaniya Sarasavi Mata Siya Desakitu Gosa Urumaya Suratina Siya Suwanda Vidu Kirana Behadena Sarasandaki vidulakare udagina Kalaniya Sarasavi Mata Kalaniya Sarasavi Mata. Viviturunana guna Yugayan yugayat Hayata tilinatara Karupirivara saha mululova sarasana Kalaniya Sarasavi Mata Vidu ambare babaleva Siya desakitu gosa urumaya suratina Siya Suwanda vidu kirana bedadena Sarasandaki vidulakare udagina Kalaniya Sarasavi Mata Vidu ambare babaleva.
Thank you. Thank you all. Thank you all. Now I graciously invite. Thank you all. Now I graciously invite Senior Professors of R.B. Kalingamudali, Dean, Faculty of Science, to welcome the gathering.
Very good morning to all of you. Vice Chancellor of the University of Kelaniya, Senior Professor Ms. Nilanthi De Silva, Guest of Honor, Senior Professor Ajit Dialvis, Department of Chemical and Process Engineering, University of Moratuwa. Keynote speaker for this morning, Dr. Charit Nanayakara, Principal Scientist, Applied Materials, Gloucester, USA. Plenary session speakers, Dr. Christina Camara, Pediatric Oncology, Cancer Biology, Dana-Farber Cancer Institute, Harvard Medical School, USA. Dr. Sampath Gamage, University of Georgia, USA. Dr. Janak Vedagedara, Cytel Statistical Services and Software UK Limited, United Kingdom. Professor Jing Yong Su, Harbin Institute of Technology, Shanshen, China. Dean, Faculty of Graduate Studies and Chairman of the Research Council, Senior Professor Kapila Sinratna. Dean of the Faculty of Social Sciences, Professor M.M. Gunatilaka. Dean of the Faculty of Commerce and Management Studies, Professor Bandaravani Nayaka. Registrar of the University of Kelaniya, Mr. K.K.K. Dharmatiraka. Librarian, Dr. C.C. Jayasundara. Heads of Departments, Senior Professor Ruwan Vijayasundara. Physics and Electronics, Senior Professor Deepika Amarasinghe, Zoology and Environmental Management, Professor Janaka Vijayanayaka, Industrial Management, Professor Jeevantha Premaratne, Chemistry, Professor Senaratnayaka, Plant and Molecular Biology, Professor Aruna Vaninayaka, Sports and Exercise Science Unit, Professor Vayanga Ratnayaka, Microbiology, Dr. Sujiva Vijayasiri, Mathematics, Dr. Chadita Attanayaka, Statistics and Computer Science, Dr. Nalin Varnajit, Software Engineering Teaching Unit, Conference Chairperson, Dr. Chamila Kadigamua, Conference Secretary, Dr. Meda Gunaratna, and other organizing committee members, academic staff members, administrative officers, technical team, research scholars, authors, and non-academic staff members. On behalf of the organizing committee, as the Dean of the Faculty of Science, I extend a warm welcome to all of you for the inauguration ceremony, keynote speeches, plenary speeches, and technical sessions of the ICAPS 2023, the International Conference on Applied and Pure Sciences. We are commencing this conference at a significant juncture as the University of Kelaniya has achieved a notable position in the year 2024 Times Higher Education World University Rankings. These rankings, as you all know, widely acknowledged and as the most prestigious and influential global university rankings were published in September of this year. Our university proudly stands at the 3rd rank in Sri Lanka. The Faculty of Science played a pivotal role in this achievement, contributing with 245 Scopus Index Journal publications from 2019, including 38 up to September this year. Further, since 2019, we have secured 3 Patent Cooperation Treaty publications, 15 Sri Lankan patents, 4 Sri Lankan industrial designs. Of these, up to now, 7 patents have already been commercialized, and this reflects the quality of research and innovations conducted by the Faculty of Science and its members. This marks the 8th consecutive year of organizing this conference, which is themed Sustainable Development through the Advancement of Science and Technology, and is being conducted in physical mode. The conference consists of 4 tracks: Biological Sciences, Multidisciplinary, Research, Physical Sciences, and Software Intensive Systems. As common for any conference, the primary goal of this conference is to provide a platform for both local and international scientists to present their findings to a broader audience, both nationally and internationally. Ensuring the quality and standards of this international conference involved a rigorous review process overseen by distinguished experts, and we achieved an acceptance rate of approximately 85%. In closing, I wish to express my gratitude to the organizing committee for their wonderful efforts bringing this event to fruition, and I extend my best wishes all presenters and participants for highly productive and fruitful day ahead. Thank you.
Thank you, sir, for your kind words. The Faculty of Science, University of Kelaniya, is delighted to organize and host the International Research Conference for the 4th consecutive time. Throughout the journey, the support and the contribution of the entire university was incessant. On that note, this warm invitation is for the chief guest of ICAPS 2023 and Vice Chancellor of the University of Kelaniya, Senior Professor Nilanthi De Silva, to address the gathering.
Good morning, ladies and gentlemen. Dean of the Faculty of Science, Professor Kalinga Mudali, guest of honor this morning, Professor Ajit Alvis, Dean of the Faculty of Graduate Studies, Professor Kapila Seneratna, Dr. Kadigamua, our conference chair, and the secretary, Dr. Veda, the other deans who are present here today, the registrar, the librarian and assistant librarian, other members of the academic staff. It's a real pleasure to be here with you in the science faculty today. I recall that the ICAPS 2020 was probably one of the earliest research conferences that I addressed when I first assumed duties as Vice Chancellor in this university. And we did that online. I think we had another one online, and then last year we went back to a hybrid mode. So it's good to have everybody back together physically now. And I believe the conference dinner is also being held physically after 4 years. Conferences like this provide an important platform for talking to each other about the research that is being done, to review the work from a critical point of view, to look at what is good, what can be done better, and so on. As Professor Kalinga Mudali just said, 2024 is a milestone year for our university because we made it into the Times Higher Education World University Rankings for 2024 for research universities. And I stress that point because unlike other ranking systems, the THEWR really focuses on the research output. And I know that the science faculty has played a pivotal role in propelling the University of Kelaniya into that band of 1,904 universities worldwide that have been ranked this year. Out of some 2,600 universities that applied, only 1,904 were ranked. And that is because we need to have fulfilled certain baseline criteria, 1,000 publications over the previous 5 years with 150 in each year, and so on. While congratulating ourselves and the science faculty in particular on this achievement, I'd like to remind the academic staff, our postgraduate researchers and our students that we need to maintain this position and improve it because we are in the 1,500 plus category, that is the lowest of the lot, whereas Colombo and Peradeniya are in the 1,000, I brought a printout, thank you. Colombo and Peradeniya are in the 1,100 to 1,200 category. So this year, Times Higher Education World University Rankings moved from using something like 13 metrics to 18 metrics, sort of indicators by which they measure the performance of the university. And in the 2024 rankings, they use not just the research productivity, which contributes 5.5% to the total score of a university, and that is the number of publications published in academic journals indexed in Scopus database per scholar. They have also brought in 3 new metrics that relate to research strength, research excellence, and research influence, in addition to the citation impact as a measure of the quality of the research that we do. And although we are okay with the aspect of research productivity, those areas, research strength, research excellence, and research influence, the research quality overall is an area in which we have a lot of room for improvement. So I urge our academic staff to set your bar a little bit higher than what you have been doing up to now. Look at where you can improve the impact of your research by looking at it in relation to what is being done internationally, and sometimes, focusing on what is relevant to Sri Lanka, but also can be extrapolated from a Sri Lankan context to what is happening in other countries, can be of value. So, and then when you write up the research, we need to hone our skills in writing in a way that will meet the review criteria set by the journals in our own disciplines, and then be able to target not just any old indexed journal, but the Q1, Q2 journals rather than Q3, the ones in that Scopus indexing, not the third or fourth quartile, but the first and second quartiles. So while congratulating ourselves on this achievement, let us remind ourselves that we have a lot of room for improvement and strive to make ourselves. I'm not talking about ranking within Sri Lanka or ranking internationally, but recognizing for ourselves where we are now and what we can do better. So just think of it from that perspective, and I'm sure we can grow from strength to strength as a university, and I'm confident that the Faculty of Science will continue to play the pivotal role that you have played up to now in promoting the strength of research that is conducted in the University of Kelaniya. Thank you.
Thank you for sharing your valuable thoughts with us, madam.
Dear Sir, Senior Professor Sudata Adhikaliga Mudali, Dean, Faculty of Science, this warm invitation is for you to present a token of appreciation to Senior Professor Nilanta De Silva.
Thank you. I request you to bear with us for a moment. Once again, I cordially invite the Vice Chancellor of the University of Kelaniya, Senior Professor Nilanta De Silva, to launch the e-proceedings of ICAPS 2023.
Thank you, sir and madam. This respectful invitation is extended to Senior Professor Kapila Sinivaratna, Dean, Faculty of Graduate Studies and the Chairman of the Research Council of University of Kelaniya to address the gathering.
Good morning, ladies and gentlemen. Vice Chancellor, Professor Nilanthi De Silva, our chief guest today. Professor Ajit D. Alvis, Professor Kalinga Mudali, our senior Professor Kalinga Mudali, our Dean of the Faculty of Science. Dr. Chamila Kadigamu, our Chairman of the Organizing Committee, and Dr. Medha Gunaratna, Secretary. Professor Gunatilaka, Dean of the Faculty of Social Sciences, our librarian, our registrar, and all the heads of the departments, and Dr. Charit Nanayakar, the familiar name to us, our keynote speaker today, and my dear colleagues in the Faculty of Science. It is a great pleasure to be here at this glorious moment of the annual research conference of the Faculty of Science. Since its inception in, I believe, in 2016, and this conference has been held without any interruption, unabated, for last several years, despite the problems we had due to economic crisis, as well as the COVID pandemic. And that shows your courage, and it is truly praiseworthy. And also, I take this moment to thank you, as our Vice Chancellor and our Dean mentioned, about our Times Higher Education rankings. And I, as the Research Council Chairman and also a member of the ranking committee of the university, I want to thank you for your huge contribution to this. And actually, when I see the statistics, the Faculty of Science and the Faculty of Medicine are the biggest contributors to the research component of this university. So it is, we really appreciate your service. And also, as the Research Council and also as the ranking committee, there was a time we were really worried how to maintain our research record, because we had problems in the country and we don't have funding and transport problems, a lot of issues. But when we look at our publication record, even that time, it has gone up. And how did this happen? And the way I understand is, these researchers, while they are staying at home, they didn't play cards probably, and they wrote papers from their completed work. And also, they wrote review papers. And that really helped us to achieve our standards. So it is, so your courage and your enthusiasm is truly invincible. Thank you for that. And also, now, though we have got the position in the ranking, and this is the time to climb the ladder and look at our competitors. Though Vice Chancellor doesn't want to mention our competitors, we as the Research Council and also as the ranking committee, we have to consider about our competitors. Look at University of Peradeniya. They have so many faculties. Faculty of Agriculture is producing a lot of publications. Faculty of Engineering, which we don't have. So they are big universities. So we need to get all the researchers and all the faculties actively involved in publishing, not only science, not only medicine. And that should be our vision of the Research Council in future. Encourage all the researchers, and that is what we are trying to do. So, few other things I want to mention, that we understand that we lack funding these days, and it is really difficult to get things done and buy our chemicals, and there are lots of problems. Now, with the generous allocation of money to the Research Council by our Vice Chancellor. We are going to introduce another funding scheme very soon, and that is to write papers. And that means you can write review papers, you can hire a research assistant to write papers. Or if you have almost complete work, you can hire a person to write your paper. We'll fund that and we'll introduce that scheme very soon, and we need a lot of review articles and also systematic reviews as well. And if you have some almost complete work, you can get, and we give 6 months, and full-time research assistant can shape it to a paper. So that is what we are going to do next as the Research Council. Hopefully, I just inform you, you can get ready in future, and the document will come to the Senate very soon. The other thing is that I noticed that most of the researchers in the Faculty of Science are well-established people. Most of them are professors, actually. So they still continue to conduct research and publish. So it is a good trend, because so they do it for joy, intellectual joy, I mentioned. So they enjoy research, and that is the only way for us to sustain our research. If we stop research at a certain point when we achieve something, we cannot go ahead. So it is the good news. Even our retired people do research. So it is a very good trend. It's a very good trend. So I hope you will continue your good work. So wish you all the best, and I congratulate our presenters and hope you will continue to make our university proud. Thank you.
Thank you, sir, for your valuable thoughts. The presence of the leading renowned researcher, Dr. Charit Nanayakkara, as the keynote speaker today is a privilege. This kind invitation is extended to Dr. Medha Gunaratnam, Secretary of ICAPS 2023, to introduce the keynote speaker, Dr. Charit Nanayakkara, Principal Scientist, Applied Materials, Gloucester, Massachusetts, United States of America.
Thank you. It is my great pleasure to introduce Dr. Charit Nanayakkara, the keynote speaker of International Conference for the Applied and Pure Sciences, ICAPS 2023. Dr. Charit Nanayakkara is currently working as a Principal Scientist for Applied Materials, Massachusetts, USA, where he developing next generation semiconductor technologies. Dr. Nanayakkara obtained BSc Honours degree in Chemistry from the Department of Chemistry, University of California, and PhD in Chemistry from the Department of Chemistry, University of Iowa, USA. During his doctoral studies, he worked on nanotechnology and surface science research. Dr. Nanayakkara was also a postdoctoral research associate at the Department of Material Science and Engineering, University of Texas at Dallas, USA. His postdoctoral research was focused on developing thin film deposition processes and understanding the film deposition mechanisms for various semiconductor applications. His transition from academia to industrial research and development started with the deposition material research and development at EMD Electronics, Massachusetts, USA, which is the semiconductor material business unit of Merck. During his research and development work at EMD Electronics, he worked on developing new atomic layer deposition processes. He also worked as a senior process engineer for ASM Arizona, USA, where he worked on developing atomic layer deposition process equipment. During his industrial research and development work, he had worked on developing new atomic layer deposition process and chemical vapor deposition process, and also equipment technology for the next generation semiconductor applications. Dr. Nanayakara has contributed over 15 Science Citation Index journal articles, and his citation record is over 1,000 with an H index of 11. Now, I would like to invite you to deliver the keynote speech. Over to you, sir. Thank you.
Thank you. Can you see my screen? Can you hear me?
Yes, sir, we can clearly hear you.
Okay. Thank you for the introduction. First of all, I would like to congratulate the University of Kelaniya, my alma mater, and the organizing committee for organizing the International Conference on Applied and Pure Sciences, the fourth one in 2023. And give me a second. Okay. It's an honor to be the keynote speaker on this scientific event. And today's talk, I'm going to talk about the overview of the semiconductor industry and how we are making the devices or the chips and different types of physics and chemistry behind that. And then a little bit more about what I am doing, the thin film deposition. And at the end, I would like to introduce some of the current trends. The trends have been a little bit changed after the pandemic, and the opportunities that are probably going to be available for Sri Lanka in future. So, the industry is basically, it's moving, the semiconductor industry is moving from a mobile-centric society to a data-centric society. So what that means is we have started using mobile phones or smartphones since 2010, 2014 timeframe. And then just before the pandemic, and even within the pandemic, that started to become more about the data. So basically, everything we create, or these content creators, or the research publications, anything, even with this call. So this is, all of this is data. So because of this huge amount of data, the industry is going forward with faster and smaller electronic devices. So if you look at the trend, it's at the beginnings, 70s, 80s, or even early 2000, it's more about computer centric. So all about the personal computers. And then came the mobile phones. And now it's about data. So data is more valuable, and how fast the data can be processed is determine the value of that data. And again, the consumer demand. So the consumers, the people who use the devices, or basically the internet, or things like that, their demand drive the need for the next generation devices. So it's demand, it's driven by the demand and the data-centric society that we are getting into. So this slide, I want to show basically the overview of this industry. So, we hear a lot of these names, but sometimes we are not sure how these names of these big companies, how they're related to each other. So there are these major chip production companies those are called factories. So those are basically factories, and in simple, they are called fabs. And the world's largest manufacturers, mainly the three main are Samsung Semiconductor, and then Taiwan Semiconductor Manufacturing Corporation, it's called TSMC, and then Intel, which is in United States, and then SK Hynix. It's not really popular in terms of the name, but they make the memory chips. It's in Korea, and then Micron, which is in USA, they also make memory chips. So usually everyone knows about these three, but these three also are big manufacturers. So the reason I put this arrow here is, so if you think about these companies, Apple, Qualcomm, or NVIDIA, they don't make their own chips. What they do is they give their design to someone else, so someone else will make the chip for them. For example, Apple gets their processor for their phone from TSMC, from Taiwan. And Qualcomm gets get their chips from Samsung and TSMC both. And then what they do is then they sell that chip to other companies, or they use it. So some of these manufacturers, they are called contract manufacturers. The reason is they make the chips and they make it for someone else. So they are called contract manufacturers. So then comes the equipment manufacturers. So this is the industry that I am part of. And these equipment manufacturers, they make the machines that make the chips. So the equipment manufacturers, they don't make chips. What they do is they make the machine that is going to be in the production line that makes the chips. So there are a number of different manufacturers. So the biggest ASML, its headquarters in Netherlands, Applied Materials in USA, and then Lam Research in USA. So they make different types of equipment, and they have expertise in those fields, making those machines or building those machines. So then comes the chemical suppliers. So these machines need material or chemicals to build the chips. So the well-known chemical suppliers, Merck, Air Liquide, and then Entegris. So these are well-known semiconductor chemical suppliers or material suppliers. So how do we build the integrated circuit, or how do we build the chips? And in general, they are built in a place called a clean room, and it's much cleaner than a hospital operating theater. So if you look at it, the operating theater would have about 10,000 particles. The fab, or the place that the chips are being made, the particle level is 10 particles. The reason is even a tiny particle that's on the surface of a chip manufacturing process can basically destroy that chip or the performance. So then the equipment manufacturers, they build these equipment. So this one, the reason I put this one is this is the most expensive equipment in the chip manufacturing, and it's used for the patterning. It's called EUV lithography tool, and so you can see, there are a couple of people here, so you can sort of get an idea of the size of the equipment. And right now, this one is about 250 million US dollars each one. So it's very, very expensive. And a simple one, the ones like here, they could be ranging from a few millions to tens of 20 millions. So in terms of having a factory, it's a big investment for these companies to get these tools and set up a factory. And the chemical manufacturers, they are doing the groundwork for new materials. So what they do is they synthesize new materials, they do the cost reduction, they try to supply the increase in demand. So here, what I have is how the semiconductor industry is doing its innovation. So if we look at, so this is from the one of the latest phones, the iPhone 17. So if we took a cross section of its logic board, so you can see it has number of different chips, so many of them, and they are all built by different companies. So there are list of companies that build these chips. Apple basically doesn't build any of those. What they do is they buy most of them, and their processor, it's even though they have their logo, it's been made by TSMC. And then what they do is they ask Foxconn, a company in Asia, to assemble it and assemble and package the phone and then deliver to the market. So when we had this conference back in 2021, at that time, I think it was iPhone 14 or 14 or 13. That one had the processor A15, which had 15 billion transistors. And this year they released A7 iPhone 15, which has the processor A17 with 19 billion transistors. So in 2 years, we can see, it went from 15 to 19. So they keep pushing this curve. And then here, this is the Qualcomm. Qualcomm is one of the designers, and then they built the chip using Samsung. And then this is the processor that's going to Samsung phones, Samsung latest phones. And that one has, I think, 13 billion transistors. So what we can see is, based on this trend, we are going through some sort of a trend, and that is called the Moore's law. What Moore's law says is number of transistors in an integrated circuit doubles about every 2 years. So far, since the inception, even since the 1970s, we were able to keep the Moore's law consistent. So this is another example of how the transistors are being built. So a simple transistor has a source and drain and a gate. So this is a planar transistor. So these used to be the transistors maybe 10 years ago. And then when they wanted to make them smaller and smaller and smaller, they started going through these other designs called FinFET. And now they are working on getting this new design called gate all around. So you can see it used to be planar, and then it became more of a 3D or more of a 2D architecture, and now it's going 3D, and it's going up this way. And so then the other part of this industry is the memory technology. So so today, I was only going to talk about these two, the logic and the memory. But as you saw in 3 slides before, there's number of different chips. So there's so many of different types of chips. And the reason we talk about these two, because these two are the most advanced types of chips. So for the storage, this is called non-volatile memory. So this is where you store your data, in your phone or in your computer hard drive. So that's this non-volatile memories, 3D NAND. It's called 3D NAND. And you can see over time, this is like a skyscraper. So it's getting higher and higher and higher. So this was built in 2021. This is 2021. So this data is from 2021 or 2019. It was from 2019. So this might be even higher now. And then there's the other one, the volatile memory, which is temporary memory for the faster data processing. That's also another type of memory technology that's keep innovating with this trend. So now let's move to how these chips are being made. So if you look at it in a way that the complete process, this billion-dollar factory, it runs in this simple logic. So there's sand, and there are companies or manufacturers. They take sand and then they build the silicon wafers. So the journey starts from sand, and then we get the silicon wafers. So once these wafers get into the factory, they go through cycles of this. They go through implantation, deposition, photolithography, etching. We will briefly discuss each of these. And after it goes through this cycle many times, maybe a few hundred times, few hundred steps, eventually we get the finished wafer. So finished wafer has the devices on it, and then there are instruments that will break this chip, that will break the wafer into smaller chips, and then assemble, and then we can put it into our devices, our phones, computers, and things like that. So so let's look at the implantation. So the implantation is it's basically the idea of the word itself. So we have a film, we want to implant some other material into that. So the way basically this is purely a physics application. The science behind it is physics. So we have to ionize the material that we need to implant, and then direct it, and then implant it. So how do we know it got implanted? We can check the electrical properties like resistivity of the layer. And most of the people who work in this field, they're physicists, and they work on how to create ion beam, how to divert it, how to focus it, and building those type of tools. And then the photolithography and etching. So I wanted to make this very simple to give the idea of what is photolithography and etching. So the photolithography is, we have something called photoresist, and then using the ultraviolet light, we transfer this mask into the resist. So once we transfer it, so there's two lines got transferred, and then when we develop, those two goes away, those two lines go away. So initially we didn't have a pattern, now we have some sort of a pattern, we have lines, and then these lines can be etched. So this is a cross section of that, so we can etch it using some etch chemistry, and depending on this material that we are etching and the incoming etching material, it becomes a more of a chemistry problem, and how we can etch it, what should we use to etch it, and then it's basically a chemistry problem after that. And now let's look at the deposition part. So this is the one I have been working for so many years, and there are three deposition techniques in the semiconductor fields. One is physical vapor deposition, the other one is chemical vapor deposition, and atomic layer deposition. Physical vapor deposition is basically vaporizing element and then depositing it on a surface. So we can do sputtering and then deposition. The chemical vapor deposition is basically having two reactants react with each other and depositing a film or forming a film. Atomic layer deposition is a special kind of chemical vapor deposition technique, which we'll have more information in the next slide. Now, once we form this film, how do we characterize that? So then comes our characterization techniques, which are basic techniques. For example, ellipsometry, which uses optical properties of the film to get the film thickness. It's a really simple technique. And then SCM, TEM type techniques. The composition and impurities, XPS, X-ray photoelectron spectroscopy. Cross-section view. So if you want to look at a cross-section like this, SCM, scanning electron microscopy. How smooth this surface is, then we can use these techniques for morphology. And what's the crystallinity of this film? Then comes X-ray diffraction, X-ray reflectance type techniques. And so then the FTIR for bonding information, electrical properties, other dielectric constant or resistivity measurements. So as you can see, the implantation, photolithography, and the deposition, all these modules, they use basic science, physics and chemistry of materials, and then it's that science is put into a expensive machine that machine will do that continuously, so the factory can produce the wafers. So in atomic layer deposition, it's a simple technique. Basically, it has 4 steps. First step called the precursor pulse. So if there is a surface, we will use so in this case, it's the trimethyl aluminum. So if we expose this surface to trimethyl aluminum, these OH and methyl groups, the hydrogen and methyl groups react, and then it forms a layer of aluminum dimethyl type layer. And then the byproducts gets out. So the next exposure will be water, which water will convert these methyl groups into OH groups. So now we are back to the starting. So if we continue this, we can build layer by layer into a certain thickness. And it's the most advanced deposition technique that the industry is using right now. So this slide, I wanted to give a little bit of different types of reactors. So there are these flow type reactors, which gases coming from one side. We have a substrate here, gases going out from this side. And then there's this shower head type reactors, gases coming from top and then goes around and goes to the exhaust. So now this part, the tool or the machine does this. So in the industry, the tool makers or the equipment suppliers like my company, we build these machines that does or that gives the specific thin film with the specific properties. So this one, again, another example of atomic layer deposition. So what happens is because this is a surface, it depends on the number of surface sites available for the reaction. We can expose the surface to the different lengths of precursor, but after some time, it doesn't matter how much more exposure we do, the surface sites are already reacted. And this is a film deposited using atomic layer deposition. It's highly conformal or highly uniform, and you can see the thickness of the SiO2 film at the top versus bottom. They are all almost similar. So we can get a conformal film. We can control the deposition rates, and that's the advantage of this technique. So now let's move to some of the applications of the ALD. So one of the applications I picked was this high K metal gate oxide. So what happened was, in a transistor, there was source and a drain, and they started, and then there's a gate. So if we apply a voltage to the gate, the electricity or the current passes from source to drain. And when they started making this smaller and smaller and smaller, around 90 nanometer, it was too small, and then this voltage started to leaking. So it started leaking, and this switch basically stopped working. So what they come up with was to add a small layer, a very thin layer of hafnium oxide. And this was introduced 2008-9, around that time. So 2006, actually, yeah. And then with the atomic layer deposition, you can get really control of the thickness of the film. And there are other applications, like if you want to do a spacer like this, and then if you want, if there is these type of holes, you can fill them uniformly. So things like that. So it's a uniform deposition technique. So this is an example that I picked because this has more application, or how we can apply chemistry and physics to a real world application. So this is already happened. This problem already happened. So think about that. There's a copper. So in the industry, the copper is used for electrical connections. So now let's say we have this width of the copper line, And what happens if we keep making it smaller and smaller, like here? So if this is here, if the length is 50, there's some resistivity, some resistance. So when we make that width smaller and smaller and smaller, the resistivity started going up and up and up. So what they wanted to do eventually, at some point, they realized they cannot use copper for this application when it's too small. Then they decided to use cobalt, a different metal. And there are other metals that the industry is looking at. And so this is an example of a machine or equipment that was developed from my company. So I picked this example because it's not just one machine. So it has multiple machines connected to a central platform. And each of these machines, they can do something specific. So for example, so if this is incoming, just think about this is incoming. The first one can do physical vapor deposition titanium. And you can see the physical vapor deposit more at the top, less at the bottom, because, more at the top and the same amount at the bottom, nothing on the side walls. Nothing on the side, because the physical vapor deposition is just evaporation and deposition. And then they do a atomic layer deposition, a thin layer of titanium nitride. And this step, they are again doing physical vapor deposition of cobalt. So it's only line of sight. There's nothing deposits on the side walls. And they do a heat up which is called anneal. They do an anneal to make it densify. This is the anneal step. And then they do more physical vapor deposition cobalt. So now it's going from here to here. It keeps going up and up the thickness. And then they do something called planarize. It means they will etch the top part and they get the final structure here. So this is one of the classic examples of how this end product or the end device or the end structure was achieved starting from this structure in a single tool. The wafer or the substrate never came out. It went through the chambers and then final product came out of this tool. Okay, so now since we are at the end of the talk, so I wanted to bring up what's happening in the industry, in the semiconductor industry after the post-pandemic world. So as we know, so we had the COVID, now there's now we are in a world that's after the COVID. So this book came in, I think 2022 by a professor called Chris Miller. So what he talks about is basically chip war. It's the access to or the control of the technology that builds the semiconductor chips. And the reason he started writing this book was, if you look at this news article, so this one, Intel is going to spend billions in new fabs in Germany and Israel. So this is 2023, June, this year. So Germany spends 11 billion of TSMC. So remember, the TSMC is the Taiwan chip manufacturing company. So the Germany wants to bring one of those factories into Germany. And then United States asked the TSMC to build a semiconductor fab in Arizona. And they already committed and they started building. I think they're trying to get into the production next year. So these two news highlight that the production in Taiwan is the other developed countries. They're trying to bring that into their own countries. And at the same time, the companies, the semiconductor manufacturers, they are investing more money to build new fabs. And with this news, what comes, this came more recently, that they started building factories, but they have a clash of the working culture, finding the right talent and things like that. So there's new problems coming through. And there's a trade war which which there's the access to some of the critical technologies has been limited by the Western and the North American countries. So the access to those technologies are limited, and then China is trying to come up with their own technology. So this news came really recently, I think 3 months ago. Micron, as I mentioned earlier, that's the biggest memory chip manufacturer in USA. So they announced they want to start a factory in India. So this news came about 2 months ago. So what we see is the bigger manufacturers, semiconductor manufacturers, they are building new factories, and at the same time, some of them started thinking about starting a fab next to Sri Lanka in India. And at the same time, there's some slowing of the global economy after the pandemic, and it's still happening. However, these companies, they are spending billions of dollars, and the industry, semiconductor industry, is going to be the complete industry is going to be $1 trillion by 2030 to 2032. So these industries keep going, even though in a low growth world economy. And then there's the key semiconductor technology and equipment sales limitation to China. So there's that also going on right now. And at the same time, the world is more and more dependent on the chips. So, world needs more of these autonomous cars, more data centers, more computing power. So things like that. So the demand is keep increasing. So then I wanted to highlight that based on the theme of ICAPS 2023, the sustainable development through the advancement of science and technology, I was able to find out some opportunities in this post-pandemic trend. There are some opportunities. So one is so this is between academic and policymakers to supply the skilled. So there's a skill shortage in Asia, in North America, in Europe. There's a skill shortage of engineers and technicians who are skilled with materials, chemistry, and physics knowledge, or material science education. And the reason is, so if you look at Sri Lanka is sending so many workers to Korea, and however, they make about $1,500 per month. However, in Samsung Korea, the average salary is almost $10,000 per month. So there is a potential that this industry is a good place to supply the skills. And in terms of policy, the government in Sri Lanka can encourage more of the applied research or applied materials, chemistry, material science, chemistry, and physics type research, and by funding and by providing funding and encouraging that. And the last one is really for the policymakers of Sri Lanka, that if they can attract investment to join the supply chains of the existing East Asian and possible future Indian semiconductor industry, because with the Micron's move, so there will be a new market opening next door to Sri Lanka, which Sri Lanka can take the advantage of that. So with that, I would like to conclude my talk, and thank you.
Thank you, sir, for your impressive presentation. We sincerely appreciate your virtual presence here today and your illuminating words. Wishing you the very best in your future endeavors. Father James Keller once said, "A candle loses nothing by lighting another candle." So this is a high time to get ready to lighten up with Another vibrant iconic researcher, Senior Professor Ajit Dialvis, Department of Chemical and Process Engineering, Faculty of Engineering, University of Moratuwa.
This kind invitation is extended to Dr. Meda Gunaratna, Conference Secretary of ICAT 2023, to introduce the guest of honor for the day, Senior Professor Ajit Alves.
It is my great honor to introduce Senior Professor Ajit Alves, the guest speaker of International Conference for the Applied and Pure Sciences, ICAPS 2023. Professor Ajit Alves is a senior professor in Chemical and Process Engineering at the Faculty of Engineering, University of Moratuwa, and he currently serves as the Dean, Faculty of Graduate Studies, University of Moratuwa. Professor De Alves obtained BSc in Chemical Engineering from University of Moratuwa and PhD from University of Cambridge, United Kingdom. He also has an MBA from Postgraduate Institute of Management of University of Sri Jayewardenepura. Professor De Alves was also a postdoctoral research fellow at University of Reading, United Kingdom, and a visiting scientist at the Indian Institute of Science in Bangalore. Professor De Alves is a well-recognized environmental expert, and he has contributed to a number of locally funded and foreign-funded environmental engineering projects. He is the director of University of Moratuwa Kargil's Food Process Development Incubator and the project director of the Coordinating Secretariat for Science, Technology and Innovation. He served as the chairman of Engineering Research Unit of University of Moratuwa from 2005 to 2007. He was also the science team leader of the Sri Lanka Institute of Nanotechnology from its inception in 2008 to 2011 and chairman of the National Nanotechnology Committee at NSF from 2011 to 2012. His research interests include developing environmental friendly technologies in Sri Lanka, appropriate technologies for energy efficiency and conservation technologies for process industries, renewable energy systems, process modifications and optimization techniques to maximize yields and resource usage, solid waste management, and waste to energy systems. He is the recipient of numerous awards in recognition of his work, most notable being the Senior Moulton Medal of Institution of Chemical Engineers, United Kingdom. Professor De Alves
in your University of Kelaniya rearview mirror, right, in terms of ranking. So here I am talking about to you on research, but I suppose I should be listening. Yeah, thank you for the invitation. So let me, I thought I'll just talk about research and prompt on the researcher. Looking at the current situation that we have in the country, and then moving on to this concept of research into rupees. So we know today we are facing significant issues, and maybe sometimes we don't have any research money, and a lot of additional issues. But and even the humble egg has become also become kind of like point of contention, right? That's what we say. Anyway, so are you feel what we see as a researcher? Do we understand the power of a researcher? And that's what I want to stress. Now, these are times, maybe very challenging times, but do we think this as a time for us, an opportunity for us to really show something and then really deliver? Because everybody has problems, and normally in research, we try to solve these problems. And while solving problems, we probably come out with some fantastic output that transform not just the person who's having problems, the whole system to a new level. And you can bring a lot of examples for that. So that means we have to feel as, okay, we should dream. There's an opportunity here, not feel challenged, okay, we may get taxed like 36% and more, and how to make the ends meet as a human being, not forgetting the researcher part. But again, what we are doing, how can we use that, our abilities to change this whole dynamics of the current situation? That's what I want to mention. So we have to be doers in a sense that not just think only, try to deliver, and maybe enable the others to achieve as well, considering we as team players. So just look at, I'm not sure whether you see it clearly, but you know the story of the two humble cycle mechanics who was dead keen on research. I mean, they were not just grappling in the dark. They were keen. They were using the physics, looking at reading the research papers, even though they were bicycle mechanics, the overwrite and the Wilburite. They, from their humble bicycle shop, went in to do the first human flight in 1903. And of course, they undermine, or rather they put to shame a professor from Harvard, Professor Famulus Pepys, right? Nobody basically had heard of him really, the Harvard professor who was given $50,000 grant to get the first human flight. But he was nowhere, and probably many of us have not even heard his name, but we all know the Wright brothers, right? But that was purpose, thinking, look, we are going to do this, or rather our dream to fly, and they did. And thanks to them, we all are doing that, right? So that's the power of a researcher, not giving up, having the dream, and then delivering. You transform your system. So we have to think, this is one of our issues that we have been facing. Why we are facing the problem today is simply because of this, something we keep on mentioning. I'm not putting the hat of the University of Molatu, but I'm more putting the hat of the Innovation Agency, which we try to tell, look, the Sri Lanka's issue had been, and if you look at what Munidasa Kumaranaka said, even long before we even had independence, he passed away before that, but he said, Alut Aludyanatran Jatiya Lononagi, the nation which does not build new things will not rise. And don't you think that has been our singular problem? Because we have not been creative, we have not been doing something of value, and we don't have anything to give to the outside, and still we give maybe the same old plantation crops, and in addition ourselves, we just give ourselves, right, the labor. So it's very important, and it's interesting he said this when there were no MBAs, there were no innovation management theories, no Harvard using case study stories or for teaching, nothing of that sort. But he probably said the most underlying important point in innovation management. Need to be creative, and then need to take the creative to the end point so that society actually changes. So this is very evident when you see, going back to an Harvard Atlas of the World Economies, you see the Sri Lankan story. I mean, it's a well worth website visiting, the Atlas of economies of the Harvard University. You go to that, and you can track any country across and see snapshots as per the year. And it's little embarrassing to see the Sri Lankan one as it moves through the years, right? Because we are still selling little bit extra things on software and then on textile, apparel, and so on. But that's the story of there's no diversity, and it's been like that for stagnant for a long time. And even in those segments, the countries that have come in from behind, like Vietnam and Bangladesh, have moved ahead. And Vietnam in particular in high tech and so on. And even if you take Bangladesh, it's moved it with pharma and so on. So we have really not done this point right. And maybe as universities, as researchers, this is an imperative we must address. Because at this time, the solution lies in this change, pursuing this change and implementing it on the ground. So as researchers, it's an opportunity for us to do that. But it's important we understand the conversion of research into rupees, because without the rupees, the economy is not changing, the society is not changing. What we have not done is not be beneficial to anybody other than just maybe a research paper. So it's important for us to understand the full equation, though we are not supposed to do everything. So that's why it's important. It's nice to hear the ecosystem support that's coming. Again, listening to the opening speech, like, okay, you're introducing new support mechanisms to the researcher and enabling such. It's very important. And the same thing the government has to do to supporting the researcher and the inventor in general in the ecosystem. So I hope this is probably one story we keep on showing, but at the end of the day, this is about research into rupees, right? Where you actually move through the situation of doing bench scale research for researchers here from 2 universities, Peradeniya and Jayawardenepura, and then protecting that research. Of course, the research selection was what should we be doing so that we have a market opportunity. You didn't select the research just to be doing research. You selected the research knowing that there's a value at the end of the day, that there's a market opportunity. So this was the basis in selection, which I will come to again. So at the end of the day, they did the research, published, but of course protected before publishing it. And as a result, there was this value of sales. So US dollars 3.1 million. It didn't really end up at that point after all, but it went up with millions of dollars. And it actually saved or returned back the initial investment for Slintech by the government was returned by this effort of the 4 scientists, 4 researchers. So it's interesting to think the entire investment was really recovered or from that in that basis, and it would have continued to be done. But you know, at the end of the point, that really we went to the Indian again was sending nanofertilizer to Sri Lanka. So the story has another much more things to learn as well. Anyway, so this is about this whole equation of basic research, the applied research, protection, and then wealth creation. That wealth creation is the research into rupees. And in that process, the IP protection, intellectual property gathering is all there. So it's important as researchers, we should understand this. Why we need to create value. We are solving problems. We are also imagining new issues and coming up with solutions that will be respected by many people, and that transform the economy, right? Technically, like Steve Jobs never asked what the market wanted. He was not doing market research, but he knew exactly if I do this, people are going to love my products. And that's exactly what happened with the Apple, right? He was not doing market research. And the same thing, if you go back into Henry Ford would have said the same thing. If I ask the market, what do you want? The market would have said, I want faster horse. So because market has no idea about an automobile, so they would have wished for a faster mode of transport, and their imagination on transport was the horse, right? So sometimes market research is not. This is imagination. Thinking about the question is imagination. And in a sense, that's why probably Einstein said, what is more important, imagination or knowledge? Imagination is more important. So as researchers, we need to have that imagination. When you see the problems of the country, we as researchers should have much more imagination in looking at solutions than what the politicians are doing, which we know has no imagination, right? So the scenario is, and so this equation is very important. And Sri Lanka should understand this, and universities too should understand this importance of it. So it was mentioned, so you have contributed to this. So this is Scopus. If you see the last 5 years, like 18 to 23, there's 19,438 papers. And you see the Sri Lankan performance, very interestingly, it's nearing 50% is Q1 journals. So that's great, right? In terms of top of the journals, the top quartile that researchers are publishing, an excellent thing to do. And also when you see the field weighted citation value, the value is also above the global average, right? So you publish in Q1, that's majority, and then obviously this will have to be, the impact has to be high as well. Another point to understand though is that when you look at the patents, the intellectual property protection, what is unfortunately seen is 19,000 on the papers, but intellectual property wise, it's falling as well, and the numbers are very low. So these are also local intellectual property submissions, and not many are reaching out to the international level, which is very important if you want to corner markets, right? At least we should go the PCT pathway. So these numbers are a show of, it's a concern, because not only they are low, they're falling as well, right? So on one hand, we have good science published, good research, but I'm not saying science, good research published across all segments of the knowledge base, right? But yet, from a commercializable or valuable the finds, pretty sure some of this research that we are publishing is we are opening up, but we are not capturing the value. That's something to remember, because gone are the days when we say you either publish or perish, but now we say you patent and publish. But that emphasis is still not with us, patent and publish, because our universities at the moment still reward the publication, not the pursuit of patent, right? So there are certain things we can do. So in US, you can take a PowerPoint presentation just before the conference and put it on the mail, and you can secure rights for a time period. So that's very advantageous for a researcher, right? The university will vet the publication, your presentation, to see that you're not going to reveal anything that will be detrimental to your patent as well. So they do a quick scan, and then you send your PowerPoint presentation. You don't have to write something different, right? So there are elements that Sri Lanka needs to change to support this research and also get the economic benefit. So something of a concern that we need to address. But the power, I want to just stress on that. Like if you go back into the history of South Korea, right, you see that it's acknowledged 40 scientists changed South Korea, right? It's not a major. Now you look at the Korean Institute of Science and Technology, the KIST. If you look at the KIST story, right, the miracle of the Han River, you see it's 40 scientists coming together. Of course, there was strong support from the government and excellent facilities were given, but the facilities in a sense not, it's go and do it, and here are the scientific support, and your request is to transform and do something. So they did. So it's a story that is written and is well available for us to think that as scientists, as researchers, we have the power to transform a scenario, and we have a scenario to transform, right? And we have more than 40. Even with the significant drain of resources, we still have more than 40. I mean, if you want to push it, we can transform that. So it's very important researchers should have this concept. I know how many of you are familiar with these golden circles, right? It's about what, how, and why, right? And the most important one is why. Let's take for University of Kelaniya, let's say, okay, what is the university? We are supposed to be doing and producing graduates, research, and so on. Okay, we know what the institute has to do, the university has to do. And how we do that. We also have certain procedures of how we do that. But the most important thing is why you get up in the morning, and come to the university, and what is the behind your mind, in your mind, why are you doing this today, right? It is that why that enables everything else to be transformed. The why comes the purpose. It's not a selfish one, it's a more of a selfless one. Why you get up in the morning to do what? And you happily get up. And you see that in certain situations like in Korea, Japan, you look at this famous word ikigai, right? Why you get up in the 5 o'clock in the morning? Because to do some work and know that this work is going to help lot many other people, right? So it's that purpose, it's that why this is very, very important from management sense for us as researchers to contribute and change. So we first think why. My purpose I defined this as we need to put ourselves in the fire, in the line of duty to transform. And what we can do, we have the knowledge to do a lot of things, but are we really using that knowledge to do this change? So look at any of the Sri Lankan problems, the science, technology, and so on can do significantly. For that, we need to change the way we think and apply ourselves. So even if you take the Nobel laureates like Solov, and if you take the most recent 2018, Paul Romer, they came up and said, look, first thing, technology is the one that defines a nation, because Solov looked at how US changed in the period in 1960s to that preeminence economic position. The singular point was technology. And he won the Nobel Prize for writing that as a thesis and won the Nobel Prize for economics. Then comes Paul Romer, who wrote about the human capital, what a researcher is going to do, and researchers was important. And he wrote on endogenous innovation. And that's all about the researcher, human capital of the country. And so it was not about external support, external inputs. It's all about, while we are here, that we have the ability. And that's another thesis which won the Nobel Prize for economics. So two theories which we had to think. Science and technology can deliver, very important. And human capital working productively can do this change. We may think we all know this, all right? But anyway, we didn't get the Nobel Prize for that. But somebody wrote it in a very, very crystal clear form and got the Nobel Prize. The message is clear. So unfortunately, in our economics, we don't hear this part of the story, right? We constantly tinker around taxes and things like that, or the monetary ratios and things may be, but something to think about. So these are two, excellent narrative. So again, as a researcher, it's very interesting when a nation is in trouble, you see how the technology has been deployed, right? So you go back to President Kennedy when he said, okay, the Sputnik has gone from Russia, America became a second-class country in the space age. So they decided to do something. And what was the thing? Let's put a man on the moon, right? And not only put the man on the moon, must bring him back as well, right? Otherwise the job is not incomplete. It's not quite right. So he said that we choose landing a man on the moon, not because it's easy, but because it is difficult. Because when you solve a difficult problem only, you realize your potential as well as you really deliver something good. So, it happened, right? So we know that it happened. So he was telling that in 61 and 69, Armstrong and Aldrin were landing on the moon. And what is also interesting is on that journey, right, the Apollo 1, so it was Apollo 11 that landed on the moon. Apollo 1 burned on the ground. All three astronauts died without even going on 1 inch. They perished actually on the training platform just few months before the actual launch. So Apollo 1 burnt, right? Now just imagine, you need to be persistent, you need to understand to move on. When Apollo 1 burnt on 1967, Apollo 11 lands on the moon in 1969. So you need to have purpose, right? And you need to stick to your plan. Yes, mistakes happen, all you have to learn, but that's very important, sticking to that plan. So one of the very important points with a researcher is the research question. The research question comes from thousands of issues that we have today. But it's also important that we are not looking at a 10% change, but a 10x change. This is what in semiconductors also we talk about is Andy Grove, right? So this 10x change. So we can push ourselves, just think about the research that we are doing today and put yourself, are you in the Bohr quadrant, or are you in the Jenner quadrant, or are you in the Edison quadrant? Now, Kelaniya has all the resources to be in the Bohr and the Jenner quadrant, but also with the applied, you are in the Edison quadrant, no problem there. But I have also put one block which is dark, right? And just imagine, why all have these 4 points? So we have basic research, applied research, and disruptive research. This disruptive research connects applied and basics into something of value, right? So in a sense, disruptive research comes from Jenner. The applied comes from the Edison, right? Edison didn't come up with new theories. He connected what was known, but came out with something of even the light bulb. He didn't come up with the light bulb. He saw it and he improved on it, right? So we need to think, when you put ourselves in mapping the research question, I should be looking at not placing myself in this unknown quadrant. We should never select research. You map your research, what you are doing today. We should never think that we should be falling into that question mark point, because that research has no value. It won't add to knowledge. It won't add to the society. All the other quadrants do something to the society or to the knowledge. And maybe at this stage, so not discounting any basic research, very important. Maybe sometimes you must ensure the Edison quadrant is working. We bring knowledge, or we do it, synthesize, and put something useful, so coming out with a solution to a problem. Most of our research, unfortunately, get into this other one, and specifically in the undergraduate research. And it's an opportunity I think we are wasting, right? I'll come back to that. So research question is very important. Why I said undergraduate research as well? Why don't you think we have about 30,000 research students, undergraduates across all subject areas, maybe at any time in a public university system? All of them have to do some research project before going up in the graduation. Just imagine the power of 30,000 projects, questions aligned to deliver something solid, right? That is very strong. But you should not be doing something that you are not unhappy, or rather you know the answer. We most of the time, and specifically at that level, get into the point where I know the answer. In 3 months, I can get my certificate. There's nothing really great about the research, because what we are doing is what somebody else has done, right? That will not add value. So it's an example like here. This is Edward Tyler, right, from Princeton, who came up with his undergraduate passion of seeing something about related research about the dyes in the butterflies, right? So one is a cabbage butterfly here, you can see, but those colors, the pigments, the chemistry, the organic chemistry of understanding the compounds. And then, of course, somebody's other research work on finding some of these compounds, similar things in the liver. And then this ending up as the Alimta, which is the very first FDA drug on mesothelioma for asbestos. And within 10 months, this drug became a blockbuster drug with $1 billion+ income. And University of Princeton was actually running with the royalties of this single drug. Right? So it says the Princeton new chemistry department, everything came thanks to the royalties of this drug. And Edward Taylor was an undergraduate who wanted to do something, and he continues the passion because he didn't join the staff and worked on it to come up with this. So it's very interesting, right? You develop an interest in a problem, you look at interesting things happening, and then see what can I make use of it, knowledge to do something, and ending up as a very useful drug. When the asbestosis and the stuff, the cancer was a good one. So from a liver analysis of something on a butterfly pigment, ending up in the for asbestosis, which is much more on the lung related, the cancer drug, right? So very interesting, right? And then the university, this research into rupees, the royalties were the one that ran. And it came up to about 2018-19, the Princeton, the major money came from the sale of this drug, royalties. So one potential research into rupees, you can have a transformational effect. So it's important to think, okay, can we think about now, if you Google, you'll find 100 innovations that came from universities. When you read that list, you will feel very, very interested to see, look, what we have taken for granted has come from university research and university people in multiple areas, right? So it's important to think, okay, what is the collection from our 17, 18 universities, right? Potentially we have the ability, but we have not translated that ability, right? So these days we are compiling 100 innovation for 2018 to 2022 for Sri Lanka, just to showcase that in Sri Lanka, in certain quarters, things are happening, but the people are not knowing, or the decision makers are not aware of this. So it's a compilation, but it will be nice to see this from a university connection and the research institutes. Second point, we should very quickly, output and outcome. We should work on this, right? Most of the time, our output is like this. This is actually my shelf as well, right? But we put the thesis up there and that's the end of it, right? And maybe these days we don't produce the hard copy, right? So even less visible sometimes. So the point is you can have these outputs, which are the tangible stuff, direct stuff that comes at the end, and maybe the certificate is a result and so on. They are of value, right? And if you select your research question, these outputs are of real value, but still they will not move unless you try for that outcome. It's important. So it's like this person who is Simcha Blas, who is an agronomist in Israel, who actually identified the drip irrigation mechanism. He was seeing a tree in the desert and saw this tree is flourishing, but there was no water. And to dig around the tree, he found a pipeline that was going with a slit in that pipeline, which was releasing drop by drop water. And he identified this massive big tree only needs these few drops, but fed regularly and without evaporation, that was sufficient for the tree to grow. He became the drip irrigation founder. Of course, finding that won't do anything. He went on to change Israel, 62% land desert. Now, even Sri Lankans go and look at how the agriculture is done in Israel, right? So that's the way it has happened. So you need to translate your results, communicate outside this. Now here we are speaking to the peers. You are in the same subject as I am, right? We all are interested in knowledge, but there is a group outside who takes decisions. We do not take the decisions at this stage, right? So it's important we communicate. So we must have the ability to communicate and push and press. That's only when the research gets into rupees. Otherwise, it won't happen, right? So it's important we understand output is not sufficient. We must go to the outcome. So it's important. So it was a G1 here. So I thought I must look at this. So we are in fact a very early days. Just look at this situation of mineral science. I'm pretty sure we have the ability to do the nano conversions, the material, all the discussions that went, whether it's physical chemistry, the chemistry or the biology, to even to take microbes out of that ferrous, out of that mineral sand, right? Kalani is the only one having the microbiology. So, so this situation, just imagine what is happening today. We do excavate about this 80,000 metric tons, and this is an old one, a little, but values have not changed. I'll show you another more updated. We get about $8 million for this, sending this 80,000 metric tons, clean, washed, keeping the pollution in Sri Lanka, giving the good sand out. We get it. Then to our potential paint industry and the other few toothpaste and stuff like that, we bring about 5,000 metric tons and spend $12.5 million. Right? And then we say, from all the material science, we say this is one of the good quality sand deposits that we have, 60% titanium. So potentially 80,000 metric tons can give us 40,000 metric tons of TiO2. So the potential losses, also somebody who buys it is it's about $400 million. So you can imagine the potential, if you do the translation, if you put the science and technology, this is what the country can get. But at the moment, country send the sand, get a little bit, then buy a little bit for the much less for the paint, and pay much more to the outside. Just imagine running that equation is not a sensible thing. We have the knowledge, we have the ability. Okay, we don't have the capex to do the capital part, but that is also part of engineering, right? Working together. So this is what you need. So today it has kind of like balance. For that 5,000, we bet 20 million, and 80,000, we get 20 million. But come last month, we are still celebrating sending more sand. So this was about last month newspaper article which said, celebrating, we have seen the largest consignment of sand for the first time to the overseas. We never think about the little bit of the stuff coming for the paint industry and much, much more money we are paying. So this is where the science or the research has failed, in a sense of an ability to do, but we have not communicated forcefully. We are equally guilty maybe, right? But things have not happened, and this is the economic problem. Having the resources, knowing or the ability to knowledge, not translating it, we will continue to suffer. Has to be understood. That's the power of knowledge of science and technology. We should be able to say that, right? So it's important, this last part is just addressing this translation. Yes, we can't do that alone. Researcher sees the opportunity, but how can I do my pilot plant? How can I do my analysis and so on? So these are the two famous things. The Death Valley on the first point, you have an idea. Little bit of money is necessary to convert it to proof of concept and the pilot plant and the next stage. And then you talk about the Darwinism C, which is of course the rest of the marketing and the fail. How am I to swim across this to ensure myself firmly in international trade and business? But those are the challenges we should be taking. And this is not, that is why multiple faculties, teamwork has to come in. It's not just science. Pure science will not deliver that part, right? So unless we have the partnership, we will not also achieve it, because I know how to do it, but nobody understand, it won't get delivered. So this is the point of teamwork, and another aspect we need to have. Transdisciplinary, interdisciplinary, all that need to happen in research. And at one level, we need to understand the value of partnership, right? It's important. So we need to understand that this one, it's not researcher should be supported by the outside to achieve. And unless we do that, also research into rupees is an issue. So example like Colombo, when you see this BioClean, I always like this as a very simple example. So whenever I flush the toilet, Colombo gets some money, right? But we see the advertisement of somebody else's product flushing the toilet. We flush the toilet, some other country gets the money. So we do that with an open mind, but not understanding. So this is very interesting. So the money comes back to the next, support the research cycle, right? 150 from the large bottle, rupee 1 from the one. I'm pretty sure Professor Kalingam will also have the royalty thing coming with Kalani. So interesting to see 7 patents commercialized. So that's very, very important. The KPIs comes with the UBLs and so on. But we need to be valued that by the government. At the moment, we have a little bit of a misstep on that, understanding the value of a UBL. So this is what is meant by research into rupees, right? And this is just nursing. So my final comment is, we researchers should understand the power that we have. But we researchers should also understand that we must select our research question a little bit more carefully so that we can actually make an impact at the end. And we cannot do it alone, we need partnerships. But we have ample amount of numbers still to come together and deliver. The beauty of it is, at the end is, we should also understand that why, right? As it says, the country only recognizes that you existed if the country feels that you have done something to the country. Not if you have used the country to all your needs, but the country is ignored at the end. So with that, I'll stop. So it's very important to have, and thanks for the invitation again, and all the best for the conference and the researchers for publishing. Thank you.
Thank you, sir, for your remarkable presentation. We sincerely appreciate your exceptional service towards science and innovation.
Yes, sir. Senior Professor Subrat R.B. Kalingam, Dean Faculty of Science, University of Kelaniya. This warm invitation is for you to present a token of appreciation to Senior Professor Arjun D. Alves.
Thank you. Dearest distinguished guests, we genuinely appreciate your valuable presence and time. This kind invitation is to Dr. Chamila Kadigamul, the conference chair of ICAPS 2023, to present a token of appreciation to our honorable invitees.
Thank you, sir. Sandeepa, we should be grateful to the people who made this happen. They are the charming gardeners who worked tremendously to make this ICAPS 2023 bloom. So I would like to invite Dr. Chamila Kadigamu, co-chair of ICAPS 2023, to deliver the vote of thanks.
Okay, thank you very much. Good morning, everyone. Vice Chancellor is not here, but we should thank for her to coming, and the Dean Faculty of Science, Chairman Research Council, keynote speaker Dr. Charit Nanayakara, guest of honor, Senior Professor Ajit Alvis, all head of the departments, academic staff members, authors, and presenters. Now, actually, we are behind the time because of the technical issues and other things. As I yesterday said, thank you all is enough. I said that, but I think I cannot do that because this is a conference and there's a way to do that. Okay. And I'm going to thank for all of them. And then I started from the to thank the foremost, I convey my sincere gratitude to Senior Professor Viranti Da Silva. She is not here because of busy schedule. She left the meeting, but I should thank her because she came here. Right. Next, I would like to express my utmost gratitude to Senior Professor Sudat R.D. Kalinimudali, Dean Faculty of Science, for his immense guidance and inspiration. So you have been our strength throughout the process. Without your support, none of these would have been possible today. Then I express my heartfelt appreciation to Senior Professor Kapila Senuratne, Chairman the Research Council, and even some of these members left the conference because of their schedule, but I'm going to mention them because they were here. Then the Professor M.N. Gunatilaka, Dean, Faculty of Science, Faculty of Social Science, and Professor Bandara Vanninayaka, Dean, Faculty of Commerce and Management Studies, and Mr. K.K. Dharmatilaka, Registrar, University of Kelaniya, Dr. C.C. Jayasundara, the Librarian, University of Kelaniya. We are pleased to have all of them present here today. It's profound honor. I take this opportunity to express my sincere gratitude to the keynote speaker, Dr. Charit Nanayakara, a proud product of University of Kelaniya, and my rightmate, joining with us from USA. We are grateful to you for accepting for the invitation to deliver the keynote address amidst your busy schedule. Thank you very much for your interesting speech on timely topic while shedding light on the conference theme, sustainable development through the advancement of science and technology. I take this opportunity to express my heartfelt gratitude to Senior Professor Ajit D. Alvis, guest of honor, for your valuable insights. Your presence amidst the busy schedule is truly appreciated, and we are honored to have you here today. Then we have the plenary speakers. ICAPS 2023 was fortunate to capture the plenary speakers from different specialization areas. Here I express my utmost gratitude to all plenary speakers, namely Professor Jin Yong Su from Harbin Institute of Technology at Shenzhen, China, Dr. Janak Vedagedara from Seattle Statistical Service and Software UK Limited, United Kingdom, and Dr. Christina Camara from Oncology, Cancer Biology, Dana-Farber Cancer Institute, Harvard Medical School, USA, and Dr. Sampath Gamage from University of Georgia, USA. Thank you all. We are looking forward to your plenary addresses today after this session. I also express my sincere appreciation to Dr. Ruan Wickramarachchi, Director ICT Center, and his team for this team for their gender support to make this hybrid event, even though our keynote present in the Zoom mode, and we had the Zoom problem from the yesterday, and that's why we had this kind of technical issues. Unfortunately, they can manage the situation. And then Mr. Saman Rajapaksa, Director, Media Unit, and the team, we highly acknowledge your gender support by providing the media coverage of this event today. Then I thankful to all the head of departments, namely Senior Professor LBDRP Vijay Sundara, Head of Department Physics and Electronics, Senior Professor LD Amarasinghe, Head Department of Zoology and Environment Management, Professor WMJI Vijayanayaka, Head Department of Industrial Management, Professor WAPJ Premaratna, Head Department of Chemistry, Professor RMCS Ratnayaka, Head Plant Molecular Biology, Plant and Molecular Biology, Professor WTMP MAPK Vaninayaka, Head Sport and Exercise Science Unit, Professor IVN Ratnayaka, Head Department of Microbiology, and Dr. GS Vijayasiri, Head Department of Mathematics, Dr. MCH Attanayaka, Head Department of Statistics and Computer Sciences, Dr. KNS Varnajit, Head Head Software and Engineering Teaching Unit. It's also my duty to appreciate the financial support by our sponsors, mainly the Research Council, University of California, main sponsor of ICAPS 2023, Amro New Lanka Cinnamon Private Limited, Bank of Ceylon, Hivex Nutri Private Limited, Metropolitan Group, People's Bank, and Oral Corporation. Thank you so much for being our sponsors. I'm sure you will extend your fullest support in future events as well. Also, as an initiative event, we have conducted 2 successful pre-conference workshops as fundraising events. For that event, we had over 100 participations. So I would like to give my special thank to the 2 resource persons, Professor Anupama Dharnagana and Professor Vasana Chandrasekhara. Dear presenters and authors, you are the core of our conference. We had a huge response from the researchers from locally and internationally. Thank you very much, all the authors and the presenters in here today. And we highly appreciate your contribution to make this event happening today. The conference proceeding consists of 5 full papers and 193 abstracts selected out of 226 initial submissions through a double-blind review process. I pay my gratitude to all reviewers and editorial board members for sharing their expertise with us to uplift the standard of our conference. They are mainly our faculty members. My heartfelt appreciation goes to Senior Professor Bimali Jayawardena, Chief Editor on the conference proceeding, for dedicated to get the proceedings a successful completion while maintaining high standards of the articles. Thank you so much, Madam. I am failing my duty if I do not thank the ICAPS 2023 organizing committee, because now we are doing it physically. We are facing much more problem than the previous. Previously, we are done the physically. First, my sincere appreciation goes to Dr. Medha Gunaratna, conference secretary, for her dedication and untiring effort to make this event a success. Dr. Medha, you have done an amazing job to make ICAPS 2023 a success. Next, my utmost appreciation goes to the track chairs, Dr. Dunita Bekon, Dr. Upeksha Pereira, Dr. Pansuji Disanayaka, Dr. Dakshika Vanyarachi, Dr. Binuka Gunawardena. You have been the foundation of our ICAPS 2023. Thank you so much for your amazing work. I humbly express my gratitude to all working committees chaired by one is chaired by Dr. Kasun Primal, Web Development and Publicity Committee. Dr. Jayanka Dahanayaka, Dr. Toshini Kumarika, and Dr. Tilina Silva, publication in the Publication Committee. Dr. Tanuka Hansaminu, Professor Charit Jayatika in the Finance Committee. Professor Aruna Vaninayaka, Dr. Tinini Mahanama, Dr. Mihiri Da Silva, Dr. Jehal Senegaratna in the Event Management Committee. Even not in this, in the committee, I would like to mention two teaching assistants, Mr. Anushka Dulanjan and Chandula Suryavansh, for their support throughout the process. Finally, our loving academic staff, teaching assistant, students and non-academic staff, for your enormous support behind the screen. Today, we will have 26 technical sessions and 3 poster sessions as well. I am thankful to all the session chairs, moderators, shadow moderators, and tech leads. Without your support, an event like this would be impossible. My heartfelt appreciation to all you whose name I have not mentioned there by mistake. Okay. Now, this is a group of work. This is not by done by one night. Therefore, I would like to thank again my amazing team, organizing committee, and then we have had the young committee, not by the age, but by the academically we are young. Then we are doing lots of mistakes. That happens, and but however, our dean and our senior professors and senior lecturers always advise us, and always they correct us if we are doing something wrong, and that for that I would like to thank them again for doing that. And then this is not the end, and this is the beginning of ICAPS 2023. Okay, now the technical sessions will start and the plenary talks will be there. I invite all the academics and the students to come for the technical sessions. Enjoy the rest of the sessions and have a nice day. Thank you.
Thank you, sir. The end of one new chapter is just another beginning of another. The best part is always yet to come. With this, we have come to the end of the inaugural ceremony of ICAPS 2023. May the winds of fortune blow in your favor. Have a pleasant day. Ladies and gentlemen, please rise for the national anthem.
Thank you, ladies and gentlemen. There is a special note. Various speeches will commence at 11 a.m. followed by technical sessions. Let me introduce the each venues. Various speeches for biological sciences will commence in faculty boardroom, and multidisciplinary research will commence in A8602, the auditorium, and physical sciences will commence in A8602 at 1:30 p.m. Software intensive systems will commence in A11201.
For your kind attention, refreshments for the guests, staff members, and the participants will be served at B1223. Okay, well, congratulations all the authors on your publication, and thank you. Have a great day.
And I ask you later, after refreshments, you can